I want to go talk about the engineering studies, right? So you
Mhm,
made a really good point walking us through what an engineering study is. I
mhm.
completely agree that you need to go through the process and do a study of some sort or do an understanding of what the process is at some sort. So I would like to one, have you walk us through what that engineering study looks like for you guys. But two, I also want to go talk about another important thing that you touched on that I feel is really important about budget, right? Going in understanding what a budget looks like, because you can go do an engineering study with the thought of we're going to go completely solve this process, but if it costs $500,000 and they had
Mhm.
$50,000 of budget, they just wasted the entire engineering study. So can you
Right.
walk us through the engineering study and having an idea of what the budget or what the problem they want to solve is, and how that's valuable on the front end to be able to give them something that's actually useful on the back end?
Right. And that kind of goes back again. This all kind of hinges around narrowing your focus and being really good at something, being an expert, right? Because that does help out a lot when you really look at an application, because there's a misconception a lot of times, and because we're in a lot of industries now, like I mentioned, that don't really have a lot of automation, the understanding of a lot of it is really not there because, well, especially cost, because there's a lot of times where you could get online and Google something and say, oh, hey, that robot only costs $25,000. So the expectation of a project, they're thinking maybe 50, 60% more than that or something. But that's really a lot more than that, right? There's a lot more that goes into it when you start talking about safety and you have different electrical panels and PLCs and the robot and then of arm tooling and the fixturing and all these things that go into it. So there's a lot more. Really, the robots just really think about it's just another component, I guess you say, or another device that's actually in a cell, right? Because that's really what it is. A robot's just another. It's a little more flexible than some, but it really is just another device in there. So it's only one part of the overall cell. So doing that first is really the biggest thing, but that comes back to when you're the expert in what you do, you already have a pretty good understanding of looking at something and understanding what it is and having a, if you want to say rough ballpark idea of what something might take, right? And it's not going to be exact, it'll be a plus or minus, but usually we like to have that conversation first because when we do work, we still do work in automotive. It's a little different conversation because when we deal with somebody in automotive, they already have the kind of the understanding, right? They do a lot of robots, they do a lot of projects. So they already have an idea of what it'll take to do that. But when you go to a more manual or a industry that doesn't use a lot of automation, that education has to come first. We have to have that conversation and talk about it because sometimes there is a little bit of unreal expectations of what something like that will cost. So we do that first. So we try to have the conversation, make sure that that's there and that's understood. And then if that's good, then it goes back to what I mentioned before. We start having the conversation about, we look at the process and we really have to vet it even after we say, okay, there may be a budget there, but really, is this process going to work for automation or is the complexity too great where it should stay a manual or like we had mentioned before, like a semi automated where we say, okay, yes, a few of these tasks will work and a few are still going to have to be done manually. We start to break that down. And then, as what Vlad had mentioned earlier, is how do you do that or show that or have that concept? So, again, that kind of goes back to if you're doing something in that same space that you're good at, then you really have a lot of that to use. So, we use a lot of tools now that we can use that make it pretty easy, different simulation software, different things like that we can put together something. So once we have that conversation with the customer, we go through it. We really look at the process. We look at what some of the problems that they're having. Because normally, if a customer comes to us and says, "Hey, I want to automate this," there's a reason, right? Is it going to be I just don't have the people. I don't have enough labor to support it. I have a lot of turnover because it's a bad environment or bad ergonomics, or there's injuries a lot in this particular application. So we talk about that first because that is a big part of it, right? So if it is, let's say, an injury type thing, ergonomic, but it's not feasible or economically to go fully automated, then we say, okay, let's take away that one element that causes those injuries in that. So we may still have a operator there or somebody that's interacting with the system, but we're going to remove that portion of it with automation. So that's what we do is our discovery. We go through it, and then we dive really, once we get through that, really dive deeper in what I'd call more of the engineering study. And there's a couple ways that we do that. If it's something that is pretty familiar to us that we've done before and it's the complexity is not that great, then we will continue with that. So we have some concepts and things that we present, and then we talk to the customer about it. We start looking at, as mentioned before, cycle times, the weight of the component you're moving, so we can specify the equipment that's going to be needed. Are we conveying something, moving something? What kind of application is, like maybe welding, gluing, sealing, something like that. So we do a deep dive into that. And then that way we can really start speccing what is going to be required for. And then if it gets to a point where it's something that's really complex or something big, we may also do what part of our engineering study is that we will provide like a quotation to the customer and say, okay, this is really going to take a lot of work to come up with a simulation, to maybe give you some conceptual drawings, but this proposal will be deducted off the overall cost because we've already done it now. So we may do some design work. We may do some preliminary programming, maybe like simulation like I mentioned. We do that first because sometimes that's required because it may be a little more complex or a little bit bigger than just to go in and look at it. There'll be a lot of time required to come up with that. So sometimes we go that route. We do that. And so then we're able to do a really good job of coming up with some conceptual drawings, do the virtual simulations in that, and show how this process will actually happen. So the customer sees it. Because again, when we're working with customers that don't have a lot of automation, the biggest thing is them to visualize it, right? To say, okay, can this really be done with automation? And it's understandable because if they haven't seen it, that's our part, our side of it, to do that education and to actually show that, right? How's that going to happen? So that's usually the process that we go through during our engineering studies, to really collect that data, to do our conceptual drawings, to show how we can do that specific application with automation.